Okay, so now we would like to find the z-scores using the technology, and let's just recall that the tables that we were working with gave us areas under the standard normal distribution to the left. So if we have a z-value and we look at the tables that we were working with earlier, they would give us this percentage right here. And going back the other way, if we were given the percentage, we needed to come up with a z-score, and then from that z-score we can go back into the x realm. Well, the calculator does the exact same thing, and when it computes the z-score for you, it will always compute from the left up to the z-score value, and it will return this part. So let's just recall that this was the Police Academy testing setup, and we wanted to find the minimum score for the upper 10%. So again, sketching our normal curve, we need to first find this z-score where this upper-tailed probability was 0.1. Now, knowing that the calculator is going to return back the lower-tailed area, that is this area over here, so we need to remember that if we want to find this z-score, well, this z-score is going to work both for the upper 1% and for the lower, and how much is this tail area going to be? 90.9. So the command that will return back this purple area in our calculator is the inverse norm command, and this takes a parameter of the lower tailed area. So we can use the inverse norm. Getting a little excited here. The INV. And now we're going to enter into this command 0.9. So pulling up the calculator. Again, if your calculator doesn't do this, it's okay. For the exam, you will have the tables. I will provide the tables, so I will leave it as to your option on the exam if you want to use the technology or use the tables. So again, if we go to distribution, and then menu option 3 is the inverse norm command, and then here we'll just enter in 0.9, and it comes back and tells us that the area, or the z-score, is 1.28, which is the same z-score I believe we came up with the last time. Jump up here and do it one more time with this Pennsylvania tax return money. So let's recall that we want to find the delimiting values for the middle 50%. So again, when we draw our normal curve, our standard normal, remember, is centered at 0. So to have the inner 50%, we're going to have a z-score of z1 and a z-score of z2. So we want this middle area right here. Okay, but remember, the calculator returns back, or when we do this, we have to put in all the left-tailed area. So let's just recall that if this middle part here is 50%, then this bottom part right here is how much? 0.25. So to get Z1, we're going to have to enter 0.25 in for the area, correct? And for Z2, we're going to have to enter in how much? 0.75. But let me show you one other neat little thing. Remember when we found the z-scores, to change the z-scores into the x realm, we used the fact that x equals mu plus z sigma. And we know what mu is because that's given, and we know sigma, that's given. And once we compute z, we can plug it in. But this little routine will do it for you. It's just now we'll enter in inverse norm, again the lower area, comma, and then if we supply mu and sigma as well, this will come back and tell us what the x value for this one is and the x value for this one. We just have to do them one at a time. So if we go to second distribution, again choose menu option 3. So here I'll enter in 0.25, comma, mu, which is 792, comma, sigma, which is 103, and press enter. And I believe that 722 was what we came up with about the last time. And now if we want to find, so this is x1 right here. So let's do it for x2. So again, we'll go second distribution, menu option 3. So now what do we enter in for the area? 0.75. What do we enter in for mu? 792. What do we enter in for sigma? 103. Sounds like a radio station. Press enter, and I believe that this is about what we got the last time as well. The nice thing is, again, using the technology, we get accurate results more so than looking these things up in the table, because remember when we looked up 0.25 in the table, we didn't have 0.25. We had to go to a number that was close to 0.25. Remember when we looked up in the table, we didn't have 0.75. So we had to find the area inside the table that was closest to 0.75 and then go backwards to get those z-scores, whereas this computes accurately. Is computing 4.25 and is computing 4.75.